Okay, so when I cofactor expand the bottom row, I have 3 with a minus sign change, and then the determinant of this 3 by 3 matrix can be done using the arrow method if you want to. Okay, or you can cofactor expand again, whatever you prefer. So let me just write down that 3 by 3. Here's the 3 by 3 matrix that is corresponding to that position. I think for this one, I would recommend just using the arrow method. When you use the arrow method, remember that you simply recopy the first 2 columns over, and then you just go along these diagonals. So you'll have 0, and then minus 2, and then plus 3, and then minus 0, minus 0, and minus -1. So that comes out to 2, I believe. Positive 2. Yeah.
So we got the -3 by multiplying all of those, right?
No. This number here is just this number here.
Oh, okay.
Goes straight in there. No calculation at all. The minus sign just comes from the fact that it's an odd position here in the matrix. So the entries, I erased my cofactor expansion formula, but if you go back to the cofactor expansion formula, right, basically you're taking the entries of the matrix times the cofactors, and you're just going across, in this case we're going across a particular row, so it's going to look like this kind of an expression. This is the 3 right there. So you just copy it straight down. And then the cofactor, see, the minor is equal to 2. That's the determinant of this, but then we have an odd position in the matrix, so I really changed it to -2. Maybe it would have been better if I think of this as 3 times -2. Personally, I just like to just change the sign on this one before I go on and then just do the minor. It doesn't really matter. Either way, you get -6 here. Is that good?
Yeah.
Okay. Now I'm not done yet, by the way. This is only one term. I have a bunch of things to do. So now I've got to add another calculation to that. See, because I'm going across, I'm doing the whole row, and so far I've only done that position. Okay. So now I go to this position. This is a 1, right? So plus 1, is that with a positive or a negative? Positive, right? You can see it right here. So I don't change the sign of anything, but I do have to cross off this column and row, so I get another little 3 by 3 matrix here that I have to work with, which looks like 2, -1, 3, 0, 0, -1, and 0, 1, 1. Does that look right? This one, I recommend we don't use the arrow method. I would suggest for this one that we just do cofactor expansion. What row or column looks good? First column looks beautiful, right? Because it's just 2 times this little 2 by 2 determinant. What's the value of this little 2 by 2 determinant? 1, positive 1, right? Because it's 0 minus -1. AD minus BC. So this is actually a positive 1, and multiplied by 2, so that actually gives me 2. So the determinant of that is also 2. Okay? And then the 3rd and 4th entries of that row are both going to be 0. So I'm going to come up with -4 for an answer. So the determinant of this matrix is -4. Okay, everybody all right with that? -4 is the determinant. Next thing would be to figure out the 3-4 cofactor. Right? You have to find the 3-4 cofactor. So if I go back to my matrix here, which is getting to have a lot of lines on it now, but I'll do my best to still be able to make this work. So the 3-4 cofactor, and why again are we doing that? Is because we want the 4-3 entry of A inverse. So I have to find the 3-4 cofactor because you transpose the matrix of cofactors when you're writing down A inverse. So I need the 3-4. So here's the 3-4 position. Now what I do to find the 3-4 cofactor is I cross off that row and column. Oh boy. So I've crossed off row 3 and column 4, and I have to find the determinant of the matrix that I get after I cross off row 3 and column 4, which looks like 2, 0, and -1, 0, 1, and 0, thing is, this determinant, if I stop right here, is only the 3-4 minor. So do I need to change the sign of the 3-4 entry or not? I do. Okay. Let me ask you another question. Let's suppose, just for the sake of discussion, this wasn't a 1. Let's suppose that this entry right here was, say, 5. Does that change what the 3-4 cofactor is? You're right. It does not change the cofactor. This is a mistake a lot of people make, is that because you get used to that here. You're like, well, I take the entry times the cofactor, the entry times the cofactor. And that's true when you're doing cofactor expansion. So when you expand a row or a column, yes, you take the entries and multiply by the cofactors. But when I'm asking you what is a specific cofactor equal to, you actually don't even care what this number is. It could be anything, because all you're going to do is cross off that row and column anyway, and you just have this matrix left. And the 5 doesn't, if that was a 5, it doesn't even show up here. Everybody got that? Okay, so then we have to just do this one. How do you want to evaluate this determinant? Cofactor expand what row or column, Brandon? Do you want to? Pardon? Third row. I wouldn't choose that.
Oh,
Third column, right? Yeah, third column is a good one because there's lots of zeros there. And so I start up here at this -1. So notice what I have. I have a minus already from here. And then this determinant, we have another minus. And do I need to change the sign on that? No, if you look at the 1-3 position, you leave it the way you found it. So we found it as a -1, we leave it that way. And then we multiply by this little 2 by 2, which is 0 minus 3. So that's -3. You guys need to be just this fast by Wednesday. Really fast with these little 2 by 2s. Really fast on being able to pick up which rows and columns to work with. And you end up with -3. Okay. So my final answer is -3 over -4, which is 3 over 4. And I brought my solution key just to make sure I do everything right tonight. And that looks right. Okay. Good enough on that? Now, you see, if I had actually asked you for the whole matrix A inverse, this is only one entry out of 16 entries. So you see you would have to do this 15 more times. Of course, admittedly, the 15 more times you don't have to do this one again. The determinant is always -4, but you would have to keep calculating all of these different cofactors. You'd have to do 16 of them. Not very likely that I'm going to ask you that. You know, my tests are always designed to get the biggest bang for the buck of the time that I have that I can. And having you do many, many, many examples of the same thing is not what I'm interested in doing at all. I would much rather have you show me one thing like this and then move on to something else. So yeah, I kind of like that problem because it sort of forces you into the adjoint method, but then it doesn't make you do it 16 times. Only really have to do it once. Okay, we all okay on that? Any questions there? Okay, let's go on to another example. This is number 2, and this one I think will be fairly quick. Write the solution set. Write the solution set to x1 minus 4x2 plus x3 minus 5x4 equals 0. Okay. Try this one. We'd like to find the solutions. Anybody have any ideas what we should do? Yeah, Rosalie?
You could like, since it's only an equation, I think you could just make the variables.
Yeah, that's exactly right. This is a trick problem in a sense because it doesn't really take any work. I mean, the normal response to what should I do is sort of the panic response is, throw it in a matrix, right? So you can say, well, I'll just put this into a matrix. People do that all the time. In this case, the thing that's weird about it is there's only one row. So then when I'm asking you to do things like put it into row echelon form and everything, you're expecting to be doing a bunch of EROs. Well, not in this case, because here's your pivot. It's already in row echelon form. There's nothing left for you to do. So as Rosalie pointed out, what we really have are 3 free variables. Remember that the pivoted variables are kind of called the leading variables, and the other variables are free. So the way we usually would do that, if you recall, is we do something like this. You know, let x2 be equal to t, let x3 be equal to s, and let x4 be equal to r, something like that. It doesn't matter what letters you use. R, s, and t are just arbitrary real numbers. Okay? And so then if you solve for x1, you immediately get that x1 will equal 4 times t minus s plus 5 times r. So do you think this is the final answer I'm looking for? What's not right about it, Justin?
You have to look at it for all reals, right? For t or x2, x3, or x4.
So these 3 letters? Yeah, these need to be real numbers. Remember we had this little symbol belongs to the real numbers. Okay, so that's helpful. Anything else we should do?
Everything is like a set.
Exactly. So we want to think of this as like a 4 tuple, like 4 slots, right, that are going in here. So the first slot is the x1 slot. Be careful that you're putting the right entries into the right slots. Okay, so there's the x1 slot, comma, the x2 slot is just t, comma, the x3 slot, and comma, the x4 slot. And then you do this colon, remember that? The colon just means such that, and then you have r, s, and t are elements of the real numbers. So you can now put that, you can basically put this information over here. This makes sense? So this then is sort of the formal way to write it. When I take a linear system, what are the options for how many solutions that linear system could possibly have? Infinitely many, or 1, or none, right? It's either 0, 1, or infinitely many. Which one is it here? Infinitely many, right? Any value of r, s, and t can be taken, right? In fact, it's sort of like a triple infinity's worth of solutions, because r can be anything, s can be anything, and t can be anything. And then the first component is prescribed after you assign r, s, and t. The first slot can't be anything. It has to be whatever this expression is. Okay. But yeah, that's all there is to that. So this is a little bit of an easy one, because normally you'll have more than one equation. If you have more than one equation, then the only difference is you have to do some EROs first, and I'm going to get to an example of that. That adds a little bit of time to it. Yeah, go ahead, Chelsea.
If it was 5x1 instead of just x1, would you have to get it?
Yeah, if this was 5x1, so if we have 5x1 minus 4x2 plus x3 minus 5x4 equals 0, then what would be best would be to divide it through by 5 first. So that would be the absolute safest way to solve it. So you have that, and then you again just put it into this little 1-row matrix like this, and set up your free variables and go from there. Okay? Yeah, Brandon?
This is just like a grammatical thing, but instead of the colon there, do we do a bar before? Like in calculus 2 or 3?
You might have. It depends on, they're both acceptable.
Oh, okay.
Yeah, sometimes people use a bar for such that, and that's completely fine. I personally prefer colon myself, but a bar is fine.
Okay.
There's nothing wrong with
It's the same thing then.
it's the same thing. Okay, so while we're on this little topic, let me throw another little question at you. Oh, we're moving right along here. We'll probably be done a little early this is such a, we've only had a month of class, right? There's not that many things. Is your question?
Yeah, quick question. If you have three variables, would you generally say that there's infinitely many solutions? Yeah.
Yeah, that's exactly right. If there are free variables, which really means you had unpivoted columns when you row reduced your matrix, then you know for sure that there's infinitely many solutions. Yeah. Yeah, so we're already flying through these examples. By the way, the other thing I just want to clarify for you, the role of the review set. This is just a side thing. The role of the review session in terms of your studying. The idea here is not that you're going to walk out of here like 100% ready for the test. I don't have to do anything else, right? The idea more of what we're doing is just putting things back in your mind again that are important from the first 3 chapters, and you can be making mental notes to yourself or even writing notes to say, oh, there's something I forgot about that. I need to go back and look at it again. So feel free to do that because some people get lulled into thinking, oh, I just have to do the review packet and go to the review session, go to the office hours, and I'll be fine. But ultimately, you're in charge of yourself in terms of how ready you are. So it might be that you leave the review session. I've had this happen. People leave the review session feeling worse than when they walked in. But actually it's a good thing because oh, I realize now there's all these things I still need to review, and then you have the time to do it, before the test. So that's kind of the mindset that I'd recommend that you try and have about this. Okay, so with that little speech over with, let's try another example here. This time I'm going to actually give you a full system. So let's consider the system x1 minus ax2 is equal to 3. And then 2x1 plus x2 is equal to 6. And then negative 3x1 plus the quantity a plus b x2 is equal to 1. So I have 3 equations there. I have 2 unknowns, which are x1 and x2. And then the question is, for what values of a and b does the system have, and we have 3 choices here, no solutions, second one will be 1 solution, and the third one will be infinitely many solutions. Okay. So that's what we've seen a problem or 2 like this before, right? Okay. So while I'm erasing the board, maybe you guys can do what you think might be the first step, and then we'll catch up and make sure we're all on the same page. What do you think is the very first thing you should probably do? Exactly. When in doubt, put it into a matrix. So what does your matrix look like? What's the first row? And augmented with 3. Very good. So the x1 and the x2 don't appear, right? Because those are the unknowns. Okay, what about the second row? 2, 1, and 6. And the third row? 1. There we go. Okay, so that's our matrix. And we are being asked for the values of A and B. So A and B, although they kind of are unknowns as well, I don't want us to think of them as the unknowns. The unknowns really are x1 and x2. And we're just trying to say, well, which choices for A and B would make the system have, these 3 possible numbers of solutions. Okay, so we got into a matrix. What would you suggest would be the next thing to do? Do our elementary row operations on it, right? Okay, so this is a little bit simple because we do tons of EROs all the time, but we don't want to make a silly mistake on this because that can throw off everything and make it a mess when it's really not supposed to be. What ERO would you suggest that I do first? A12 of negative 2. Does everybody agree with that? Okay, perfect. Let's see what that gives us. So the first row stays the same. And the reason we did that is to decide what ERO to do right there, all that Rosalie had to do was look at these two numbers. They said, I want to make that into a 0 using that. So take -2 times that and add it to that. And then of course we have to then see how that affects the other columns as well. So what am I going to get for the rest of that row? 2a plus 1. Okay, and then 0. All right, good. And then, can we do another ERO at the same time? Okay, what ERO would you like me to do this time?
Multiply row 1 with -3.
Exactly. How about not -3, positive 3?
Oh, that's right.
Yeah. Okay, so take 3 times the first row and add it to the third row. So I'll get a 0 there. And if I take 3 times this and I add it to this, what does that give me? I'll do it again. 3 times this, added to this, -2a plus b. Perfect. Okay, great. And then in the last column, just 10, right? Okay, good. So far, this is a pivot right here, obviously, for sure. And now, this is a little bit tricky how these are lined up, right? The way that those are lined up. So, you know, we know that a pivot has to be equal to 1. So the next thing that you might want to do would be to multiply through by 1 over 2a plus 1 so that it becomes a true pivot, right? So if I do that, let's try that. Let's take row 2, let's multiply it by 1 over 2a plus 1, right? 1 over 2a plus 1. If we do that, then all that changes is that we just get the second row to simplify to 0, 1, 0. Third row, we're going to leave the same. By the way, when you're doing, I wouldn't mind having you like multiply several rows by different constants, but what I don't want you to do is do this operation mixed with one of these, because that starts to get very confusing as to what happened in what order, okay? Now, there's a little issue here. So if we do that, then obviously this will become our pivots, right? There is a little issue with this, which is that if A happens to be -1/2, right? If A is equal to -1/2, then what we actually did right here was we just divided by 0. Okay? So I'm going to come back to the case. So this works. This works for A not equal to -1/2. So if A is equal to -1/2, then this isn't quite right. So let's take it kind of as two cases. Okay? Let's imagine for now that this is okay and we can keep going. All right, so we've got a pivot here, a pivot here. I already know that there's not going to be any free variables, right? No free variables at all. What would you like me to do next, though? It's not necessarily in row echelon form. The pivots I have 2 pivots that are right above one another. So that's not acceptable for them, right? So you can divide the third row by -2a plus b as well, and that would not be wrong, but you would then be introducing another sort of case of where dividing by 0 could happen, right? Because anytime -2a plus b would be 0, you would have a problem with that. So instead of that, is there another ERO that would avoid having to divide by anything?
So you multiply the second row by 2a minus b.
Exactly. Exactly. If you multiply the second row by 2a minus b and add it to the third row, do you see that that is actually going to work out great? So the first row stays the same. The second row stays the same, right? So the first 2 rows stay the same, and all you're doing now is adding 2a minus b times the second row to the third row, which actually just gives you 0, 0, and 10, right? Oh, and look at what happens. That last entry, of course, I could do one more step where I multiplied the third row by 1/10. But the point is you have moved a pivot into that last column, right? So what does that tell you? Right, no solutions, exactly, inconsistent. So there's no solution. So as long as A is not negative 1/2, this whole calculation goes through correctly and we get no solutions. So no solutions if A does not equal negative 1/2 and B can be anything. So I'm just going to say B is an element of the real numbers. It actually doesn't matter what B is. As long as A is not negative 1/2, we get a problem in this, with this pivot in the last entry. Okay. So now we have to go back though, and we have to say, well, what if A did equal negative 1/2? This is the other possibility. So what you want to do in that case is, since it's only one specific value, you literally just want to come in here and put that number in for A. So I'm just going to put it in, because this is where this was the step where we did the questionable division. So let's go back to that step. 1 and then negative A would be 1/2 augmented with 3. And on the second row, it would have been 0, 0, and 0. And on the third row, it would have been 0 and what would this give us here? If A is negative 1/2, what does this number equal? B plus 1, right? B plus 1. And then this is a 10 here, right? Okay, great. Is that in row echelon form? No. So what would I need to do with this? Okay, I can permute rows 2 and 3. So I get 1, 1/2 augmented with 3 is 0, B plus 1, and 10, and 0, and 0, and 0. So now I have a pivot here. Is this a pivot? It could be is the right answer. It depends, right? So if, let's say it this way, if B does not equal negative 1, if B is not equal to negative 1, then this number will not be 0, and so we can make that into a pivot, right? And in that case, then, if the pivots come out like that, what's our conclusion? One solution, right? So we're in case 2, or case B over there, right? So we have one solution, exactly. So let's write that down. So this is a little bit of a weird combination. I didn't want to do just totally easy problems all the time. So this one would be if A equals negative 1/2 and B does not equal negative 1. Okay? So if A is not negative 1/2, it doesn't matter what B is at all, it's never consistent. But if A does equal negative 1/2, then we can start looking at B, right? And if B does not equal negative 1, we get one solution. The other possibility is, what if A equals negative 1/2 and B does equal negative 1? See, if B does equal negative 1, oh, I did that wrong, didn't I? Because if B equals negative 1, we actually get a 0 here, which means that our pivot would move over here again, right? Which means it's inconsistent again. So I put that in the wrong place. So let me go back. What I should have said here is A does not equal negative 1/2, or A equals negative 1/2 and B equals negative 1. Then we have no solutions. You see, what's weird about this is that we end up concluding that it is actually, doesn't matter how hard you try to put values down for A and B, you can actually never get the third case, which means you can never get an unpivoted column to the left of this bar, right? Without